Alright, this last video is based on the last example on your notes. It is for one a little bit challenging than the others, but still apply the rules that you have here, and then along with the ones that are down here. Especially this ones, where you have to have the same radical, radicand, and root in order to be able to combine how many you have. So our goal here is to notice that we are adding two radical expressions, but they need to be the same on the inside in order to be able to combine them. It doesn't necessarily have to be x, it could be anything, but as long as the same on the inside and root. All right, so what we want to do is break down these into seeing if they can convert into the same root, so then we can merge them, we can add them. So we break down 192, we can break it down to, for example, dividing it by 2 because it's an even number, and 192 divided by 2 is going to be 96. And then if we keep breaking down the 96, we can divide by 2 again because it's another even number. So 96 divided by 2 gives you that 48. These are primes, so we can just kind of set them aside. 48, just keep thinking of numbers that you multiply to get 48. So 24 times 2, 20 is the prime. 24, what we can do is 4 times 6. And then 4 can be broken into 2 times 2. So those are primes. And then 6 is 2 times 3. So those are primes. So technically, all the numbers that I circled is what the numbers of 192 become when we break them out into the factors. So 3, or cube root of 192, is cube root of 2 times itself, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, times itself 6 times. And then a 3. So that is just the 192. So now we need to understand what x to the 5th power is. So x to the 5th power is just the x 5 times. And then we're looking for groups of 3. So this group comes out as a 2. And then this group comes out as another 2. And keep in mind that these are all multiplying. The 3 right here stays. And then these 3 can come out. And then these 2 are going to stay. And by that, I just mean inside the radical, the cube. So inside we have a 3 and x times itself 2 times. So that's x squared. On the outside, though, we have these 2 right here, along with the 6 that we initially had, keeping in mind that this is times that. So this is what we have for the replacement of the radical. So we still do have that 6 being multiplied in the front. So 6 times 2 is 12. 12 times 2 is 24. And then there is a group of x's that came out. So we're going to just put x on the outside one time. So the coefficient is 24x, and this is the radical. Let's try the other one and see if we can simplify to the same radical and on the inside and outside. So here we do have an x at the beginning, just kind of carry it along as it goes. And this is cube root of 81. So we're going to do, again, numbers that come to break down all the way. So here it's pretty easy. 9 times 9 is 81. And then each 9 is 3 times 3. We're looking for groups of 3s. So here is one group that can already come out of the cube root. Keeping in mind that here you have x twice. So when we take out this group, we end up writing it in the front as a 3. Keeping in mind that this x is already here, and it's being multiplied times the radical. And then on the inside, we just have these 3 terms, or variables and number, and they cannot come out because we don't have them times itself 3 times. So to clean this up, we're going to have 3x on the outside, cube root 3x squared on the inside of the radical. And if you notice this and this, they now can be added because you have the same radicand, meaning the same inside part and root. So because they're the same, we can apply the rule that we could combine these two. And then we combine these two, we get 24x plus 3x, which is 27x. And then this part, because they're exactly the same, you're just going to write the expression. Technically, this is the answer. And I'm sorry I say the word technically so many times. It's probably the Spanish in me trying to keep going in my explanations. All right, so therefore that's the answer. I hope the video helped you.